Hey guys, so this is lesson 24. This one is super hard. I hope I get some hard ones that I can show you guys. I get a lot of these wrong still, so I went through it a lot of times um, just to get down different answers. So I'll be referring to my notes, but I'll try to go as fast as I can. So the drawing ones are pretty simple. Butanoyl, I just know it's going to be, we're going to draw our 4-carbon chain and then add our double bonded oxygen to the carbon. And lastly, our chloride, and add our hydrogens and hit arrange, fit. So these drawing ones are usually my saving grace because the mechanism ones are pretty difficult. But yeah, that's butanoyl chloride. Okay, so the naming, I know that this is an aldehyde. Let me make sure. And also the chart that he has on there for us, I think it's the acyl substitutions chart that we've been going over, the diagonal one. That kind of helps me through this when I'm trying to figure out the different things that they're called. So first, I know this is an aldehyde. So I'll go ahead and put aldehyde. And we have propane and ethane. So E comes before P, so I'll go ahead and put ethanoic, and then I'll put propanoic aldehyde. And let me make sure on my notes, because I don't want to do this again. Ethanoic, propanoic aldehyde. Oh, it's not aldehyde, it's an anhydride. Sorry, I had a long night last night, so ethanoic, propanoic, anhydride. Yeah, and I see on the chart if it's exactly what that was. So the anhydride is going to be kind of like a mirror effect with the 2 carbon oxygen double bonds on either side, with the oxygen in the middle, flanked by those 2 carbon oxygen bonds. Okay, here is a fun one. I'm gonna go ahead and draw this first. So I'll start with, I see the butanoyl, so I'll do my 4-carbon chain, add my chlorine, add my oxygen because it ends in oil, it's double bonded oxygen. And then there's a methyl at the 3 position, so I'll do 1, 2, 3, methyl over here. And then I see we're going to be reacting that with ethanol, so that's 2 carbons with a single bonded oxygen. Oops. Triethylamine, that is this super complicated molecule. It's ethyls on 3 points of the nitrogen. Add my hydrogens and hit arrange. So we get crazy, all this commotion going on the screen. And now I'm going to refer to my notes because I think I've done this one already. Okay, so the basic goal of this is one that I actually remember based on my notes. We're not going to do anything with this nitrogen. This is only here to remove the hydrogen from the oxygen. So first, we know this chlorine is going to dissociate. So I'll go ahead and remove my chlorine. I'll move that over here. And now I want to associate this oxygen with the carbon. Grab this bond and bring it out. hit arrange, and see that hydrogen's out. I can bond it here, but I'm just gonna leave it because we're just gonna wash all this away like he says. So I'll go ahead and delete everything else. So I really didn't need to draw that nitrogen molecule, but I guess I just did. So here it is. Turn it around so you can see all the carbons have their complete octet. We have this oxygen here with a double bond and 2 lone pairs. And then we have an oxygen here, 2 lone pairs and 2 bonds. Okay, butane dioic acid, so that's going to be 4 carbon chain. And then I see di in there, so I know I'm going to have dioic, so I know I'm going to have an oxygen double bond on 1 carbon and a single bond, and then dioic means I'm going to have the same thing on the other side, so I'll do a double bond there and a single bond over here. Add my hydrogens, hit arrange, and then I'm going to go to that chart that he had laid out for us, and I see that this is a carboxylic acid, and then when it reacts with heat, it's going to make an anhydride. So that chart really does come in handy, and in his video he showed us exactly how to do that. So basically we're going to be connecting this to form like a ring. So I'm going to disassociate this hydrogen. Oh, sorry, I'll bring the bonds back to oxygen. And now I can make this a water molecule, and I'll grab that hydrogen. Hit arrange. Now, since it's water molecule, I can go ahead and detach from this main molecule. And now this carbon here only has 3 bonds, so I can go ahead and use one of these lone pairs to attach it. Hit arrange. And I'm going to go ahead and delete this water molecule. So what we have left is the butane dioic anhydride. So yeah, if you look at the chart, you'll see like figure out what you have first. So I had a carboxylic acid, and then look at when like what it's going to be reacted with. There's another heat one, but that one needs an amine. So had there be a nitrogen, then we'd make an amide. But since there's no hydrogen, we made an anhydride. Product of ethanoic, anhydride, and water. So this is going to look similar to the one we just did, except it's not going to be a ring, and it's an anhydride. So each side's going to look the same. So I have my 2 ethanes. Anhydride means it's going to be like a mirror effect. So I'm going to make it like that. So we see my my ethanoic here, 2 carbons, ethane, and my double bonded oxygen and single bonded oxygen. Same thing on this side. The anhydride is made up of these 2 double bonded oxygens with this oxygen to create a mirror effect. And I'm going to go to my paper and see. So an anhydride mixed with water will make a carboxylic acid. So let's go ahead and try to make that. A carboxylic acid is basically, we're going to be left with an oxygen with an OH and a double bonded oxygen. So I'll use my heterolytic function And I'm gonna look at my notes too to make sure that I'm keeping on track if I have it on here. I actually don't think I have it, so I'm gonna try to do it. Okay. I know it's gonna make a water. Oh wait, and water? Okay, I know it's gonna make a carboxylic acid. So hydrolytic. Let's see what I want to do. I'm just gonna try to do it the easiest way and bring those bonds back to oxygen. And I'm gonna release, let's see, that would leave this molecule. I could grab this hydrogen. Let's try that out. So I try to make sense as I go through it and see if that's really what I'm doing. So what I have here is a carboxylic acid, but I don't know if this is the right one, but we'll see. Okay, so I'm gonna quickly just write this in my notes. Okay. Okay, so here's a naming one. The naming ones aren't too bad. So we're going to begin with this molecule. This is all excess because we want to focus on the double bond. So I see it's ethanoic acid. And it has this ethyl attached. So I'll put ethanoic acid. And I'll check my notes because I'm not too confident if we add the acid. Okay, so I'm actually wrong. It's ethanoate. That's why I was confused. So for the carboxylic acid, now it makes sense. For this to be a carboxylic acid, this one needs to have a hydrogen. But since it has an R group over here, that makes it what is it? An ester. And it's not a carboxylic salt because it doesn't have any sodium or anything. So we leave it like this. We got the ethyl portion and the ethanoate. Okay, so we're going to draw that molecule again. So ethanoate. So this is just, we got that part, and then we got to add the ethyl on this side. Methylamine. What is that? Just a carbon and nitrogen. Add my hydrogens and hit arrange and fit so I can see it. And I'm going to check my notes for this one because this one seems like it's going to be complicated. If I have it. Okay, so I'm going to look on my note on the chart that I've been talking about, the diagonal chart, and I see an ethanoate, so I know it's an ester, and then we're adding an amine, so in the end product we're going to have an amide, which means we're going to replace this group with the nitrogen. So to do that, let's see where I want to go. I try to do everything like the way we're kind of supposed to, but sometimes it's just easier to just do this and then do this. Hit arrange, and I'll go ahead and move this. And then I'll go ahead, I want to give some of those hydrogens to oxygen. So I'll just give one hydrogen, and I'll go get it with the oxygen lone pair. I'm going to roll this around, and it says products, so we want to leave all these products on here. I want to make sure that everything has the right bonds. This nitrogen has its lone pair and a hydrogen, and this oxygen here has a lone hydrogen and 2 lone pairs, and all my carbons look good, so let's check it out. Okay. I'm sorry this video is a little long. Like I said, I had a really long night. I'm trying to get my thoughts together, and yeah. Ethanol. So I got my ethane, I got my double bonded oxygen, and my chloride. And sodium propanoate. So I'll go ahead and draw the propanoate first because that's the easiest. 3 carbons. And my OAT. And add my sodium over here on this side. Add my hydrogens and hit arrange. And I'm going to go back to my chart and see what reacting that ethanol chloride with sodium will do. So I look for where chloride is. I see it's an acyl halide. So reacting that with sodium, a salt, a carboxylic salt. Let's see. Will give us an anhydride. So that gives me a good hint that I'm going to be releasing this chlorine. I'll go ahead and move that out of the way. And I need to make a anhydride, so I'm going to go ahead and roll this around. And see, putting these 2 pieces together will give me that mirror effect that I want. So hydrolytic, I'll go ahead and grab this bond, hit arrange, and I'll go ahead and delete everything that's left over because I have my anhydride exactly the way I want it. And let me check my notes to make sure that that's okay. Okay, I actually don't have it, so I'm gonna hope for the best, and hopefully I did this right. Okay. Yeah, so using that chart, honestly, I mean, it's hard to get used to using it, but this homework, as a pain as it is, it really helps with learning how to use the chart. And I know we're going to be using that for that test, so. Draw the ester product of ethanoic anhydride and ethanol. So I'm going to begin by drawing my ethanoic anhydride. So I know it's going to be, I'll go ahead and do my double bond there. Anhydride is going to be the mirror effect like I was talking about earlier. Let me draw my ethanol, just one single bonded oxygen because it ends in OL. And I know I'm gonna have an ester product. I think I got this one wrong several times, so hopefully I can get it right this time. So I'm gonna create an ester, so it's gonna have that oxygen double bond with an oxygen with an R group attached. And let me look at my notes and see if I have that. Awesome, I do. So for the ester, we're gonna remove, we don't need this because this makes it anhydride, so we're gonna go ahead and remove that and replace it with the carbon groups. So I'll go ahead, actually I think we're just gonna remove it altogether. And then we see that this carbon is missing hydrogen, so I'm gonna go ahead and take this hydrogen from here, and I'll create a double bond here. I know I'm doing it all wrong, but yeah, I'll just move this. Okay, hit arrange, and I'll go ahead and delete everything else on the canvas. So what we end up with is an ester product. So we have our double bonded oxygen with our single bonded oxygen that has, an R group attached at the end. Let's see if that's right. I think all the carbons look good. Okay, it saved the best for last. Let's see if I have notes on this, because these always look super complicated. Okay, I guess it's not as complicated when they actually give you the compound. So I see that we start with an amide. So I'm gonna go to my chart and look for amide, and we're reacting that with a carboxylic salt. So amide going to a carboxylic salt, which is a base, should give us a carboxylic salt. So I think for the most part, all I'm going to be doing is replacing this group with the oxygen here. So I'll go ahead and remove that bond, and I'll attach this new one. Hit arrange, and I'm going to add this hydrogen to nitrogen. Hit arrange, and I'm going to leave everything on the board. Okay, lone pair of nitrogen and a hydrogen, and then I got my carboxylic salt here with my sodium. So I'm going to go ahead and submit that. So when you get different things like this, sometimes it'll have like 3 or 2 other ones, not just, it'll have like sodium hydroxide and have like water or something. Do this one first, reacting with sodium hydroxide. And then once you get that molecule, then you react it with water. And using that chart, as you saw with like some of them that I didn't have in my notes, it really, really helps just to get to learn how to actually do it. So I do recommend printing that chart out. I have it here. I also have like my paper with all the different acid names, so because I know they have different like succinic acid that I had no idea was. But yeah, I recommend just having this chart here and learning what we're doing. And I was telling some of my friends too, I bought Organic Chemistry as a Second Language. It's a book, and it's extremely helpful. I think that's the reason why it's helped me so much during this homework, because I did it a while yesterday, but I wasn't really getting it until today, until after I read the book and really learned what was going on. So yeah, I'll link that on the bottom for you guys, in case you're trying to learn during this course. But yeah, good luck everybody, and if you have any questions, you can go ahead and ask me anytime.